substance.
You look at this club as a metal head on the end of a shaft.
But when you take that golf club inside the STEM zone,
It looks like an engineering marvel.
you see a golf club.
We see the center of gravity, the coefficient of restitution, and the moment of inertia. Engineering is man's application of scientific and mathematical knowledge to build just about everything we see around us.
From bridges
To buildings,
to ships.
to...
No,
not dogs. Sorry, boy.
The word engineer is derived from the Latin roots enginare, to contrive or devise,
And ingenium, which means cleverness.
Scientists discover the world that exists. Engineers create the world that never was.
just as we have different heads and faces.
Golf clubs have different heads and faces too.
Golf club engineers have two primary goals when designing clubs: increase distance and improve accuracy.
To do this, they focus on three scientific principles: center of gravity, coefficient of restitution, and moment of inertia.
I'm having a moment.
The center of gravity, or COG, is the point at which the gravitational weight of an object is concentrated.
Look how you are engineered. Your center of gravity is here.
For cars and trucks, it must be close to the road to give them stability.
Bad COG, dude. The COG of a golf club is here. This is known as the club's sweet spot.
Engineers place it lower on the club face to enhance the effectiveness of this spot at impact and increase distance.
Sweet.
When that sweet spot meets a golf ball,
What we have here is a collision.
that collision sends the ball into flight, which depends heavily upon the coefficient of restitution, or COR.
The COR tells us how much energy is lost or retained when two objects collide, or how bouncy something is.
Say one piece of sticky chewing gum collides with another. The two pieces would stick together and not move, giving them a COR of 0.0.
No bounce.
If we change the gum to billiard balls, virtually all the energy is transferred from one ball to the other when they collide. That gives them a COR of 1.0, or 1.
Big bounce.
The rules of golf state the COR of a golf club cannot be greater than 0.83.
That means if you shot a golf ball out of an air cannon at 100 miles per hour, the return speed off the face of the club could not exceed 83 miles per hour.
This helps engineers predict how far the ball will travel when it is hit by a club.
If we could stop a swing in motion,
We would see the third STEM factor, the moment of inertia, or MOI.
MOI measures an object's resistance to changes in its rotation, or how hard or easy it is to rotate that object.
When the weights on a barbell are spread apart, the MOI is higher, making it harder to rotate.
I'm having another moment.
But if you move the weights closer together, the MOI is lower, making it easier to do.
Piece of cake.
Switching from wood to metal let engineers design larger drivers and distribute the weight across a wider area.
This gives the club a higher MOI, making it harder to rotate if a golfer doesn't hit the sweet spot, helping accuracy.
So, the next time you look at a golf club,
Remember what that club looks like in the STEM zone.
it's an engineering marvel. STEM Zone, energy for learning.